Alright, so titration is a way that we can find an unknown concentration of acid or base. The idea is that you're either adding an acid to a base or a base to an acid, and it's neutralizing. And what happens here specifically is we're adding NaOH, so sodium hydroxide, to vinegar, acetic acid. And the way that we made the NaOH is we put 4 grams of this stuff here into 1 liter or 1,000 milliliters of water, since the molar mass is about 40 grams per mole. And then we used 5% vinegar, and we diluted that vinegar down, and we put 5 milliliters of the 5% vinegar, and we mixed that with 45 milliliters of water for a total of 50 milliliters. So we did dilute it down. So we took this stuff, which says that it is reduced with water to 5% acidity, and we reduced it a little bit more. And so we have our acid, acetic acid, for represented by the vinegar, and we have some sodium hydroxide solution, 0.1 molar. So what we did is we have a burette here. We filled it up to the 0 mark, and right at the 0 mark is going to be, see if we can get it focused in here a little bit. Right at the 0 mark is where it represents 50 milliliters, is kind of in there. And so we're going to add our NaOH to our 50 milliliters of our diluted vinegar. And then we also added some phenolphthalein as an indicator. We added about 5 drops. And we're going to record the pH. So right now it says a pH of about 7. That's because we have it sitting in water. We'll take this, we'll put it into here, and so we'll have our initial pH reading of our vinegar, and so we'll just kind of keep it in there. We'll stir it as we go. And so right now pH is rapidly dropping because it's an acid. And Jimmy, can I get you to stir this as we add this? So Jimmy's going to stir this real quick, and we're going to hit collect. Can you collect the data? And so we'll start this titration here. I will open up the valve and I'll have it go at a particular rate. So how about, like, we'll try to go like right like that should be good. So we'll just keep it going like that and just kind of keep a light stir on it. And so we can see the volume is going to be dropping slowly but surely as we add the NaOH to the acid. We're also noticing that the pH should be rising. We're adding a base to an acid. The pH is going to go up. And we'll keep going here. And the phenolphthalein should turn this pink when it indicates a base. And then we'll try to record when it turns. You see how it's turning pink, but it's not quite staying pink yet. And right now we are at 31 milliliters added. And we are at 33, 34, 35, 36, 37, 38, 39, and almost there, 40, 41, and 42, 43. We're pretty much done now, so we can keep going though. 44, 45. Notice how we finished right around 41, 42. We started with about 5% acetic acid. That's what the vinegar is diluted to pretty much right out of the bottle. And so that translates to 0.833 moles per liter. And we use the dilution equation, so our initial concentration times our initial volume of 5 milliliters is equal to our final concentration, which we want to know after we add the water additional that we did, times the final volume, which is going to be at 50 milliliters when we're done. And so we basically took the original concentration and we divided it by 10 to give us a theoretical concentration of that acid before the titration of 0.0833 molar. Now, in the experiment, we had the equivalence point, which is approximated by the end point when that turns pink. And at that point, we have the number of moles of our base about equal to the number of moles of our acid. And so we can say that the concentration of our base, which was 0.1, times the average endpoint from the class was about 41.4 milliliters, is equal to this unknown concentration of acid times the 50 milliliters of it that we had. And when we divide both sides by 50, we get our experimental concentration based on how much base we added of 0.0828 molar, which is pretty close. So our theoretical and our experimental value match up nicely. And then you look at the graph, we started at about a pH of 3. It kind of steadily increased, and then you have a rapid change of pH once we get to that end point, and it jumps up over a pH of 7, which is neutral, indicating a base where our indicator phenolphthalein finally turned pink.